Okay, so parallelogram with all four sides congruent. I have a picture here. Obviously, it's not perfect because I drew it by hand, but all the sides are the same length. It's like a square. Actually, a square is a rhombus. The difference is a rhombus doesn't necessarily have 90-degree angles. So the theorems for a rhombus, the first one is if a parallelogram is a rhombus, then its diagonals are perpendicular. This symbol means perpendicular. What does that look like? So let's say this is our rhombus here. The diagonals would form 90-degree angles here. Then the next one, number 2. If a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So abbreviating again, if a parallelogram is a rhombus, and each diagonal bisects a pair of opposite angles, and I'll show you what that means on the picture.
Intersects.
If a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. What does that mean? Well, I'm going to number these angles here. It means that angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4. Angle 5 is congruent to angle 6. And angle 7 is congruent to angle 8.
I'm sorry, where are we getting angle 4, 5, 6, 7, 8?
I just numbered it around.
Inside and out?
On the inside. Okay, so in a parallelogram, remember opposite angles are congruent, so therefore if this bisects that angle, then all 4 of these angles are the same measure. So keep that in mind as well. So yes, this is bisecting that angle, but because they are the same measure, all 4 of these are the same measure. And 7, 8, 3, and 4 are all the same measure for the angle. Then a square. A square drawn here is a parallelogram with 4 congruent sides and 4 right angles. So like a rhombus, it has the 4 congruent sides, but in addition to that, it also has the 90-degree angles. So a square is always a rhombus, but a rhombus is not always a square. If that confuses you, this might help a little bit. The quadrilateral family tree that we drew on the page before it can help too. Okay, so now we're going to get down to the theorems for rhombi and square combined. So there's 4 of them, and these are kind of like, they're converses to the ones we just wrote down. So number 1, if the diagonal of a parallelogram are perpendicular, then the parallelogram is a rhombus. So before we said that in a rhombus the diagonals are perpendicular, here we're saying, well, if the diagonals are perpendicular, then you have a rhombus. Number 2, if one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. And I'll draw a picture of this too. So here's your parallelogram, and it's saying that if you have a diagonal and it does bisect those angles, so if 1 is congruent to angle 2 and angle 3 is congruent to angle 4, then you have a rhombus. Number 3, if one pair of consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. So if you have a parallelogram and you're told that one pair of consecutive sides are the same measure, then they're all the same measure. And last but not least, if a quadrilateral is both a rectangle and a rhombus, then it is a square. And I'm using abbreviations, of course. If a quadrilateral is both a rectangle and a rhombus, then it is a square. And you can see that on the quadrilateral family tree as well. Okay. And then once you finish that up, we're going to move over to the workbook.